Pleasant good morning to everyone. Up to our last class, we discussed Unit 10 surface chemistry. So in that videos, we discussed what is the surface chemistry, what are the phenomena involved in the surface chemistry. There are two phenomena we have discussed. One is adsorption, next catalytic property. So followed by we discuss what is the colloidal solution. What is colloidal solution? What are the types of colloidal solution? Then how will you prepare the colloidal solution? Then what about the purification of colloidal solution? In this video, we are going to discussing about the properties of colloidal solution. Now we'll see one by one. Colloidal solutions can exhibit two types of properties, such as physical properties and some special kind of special properties. Now we'll see what are the properties are. The first one, physical properties. The special type properties are optical property, electrical property, kinetic property, and coagulation or precipitation or fluctuations. Here, the physical properties undercome shape, size, structure, solubility, filtrability, and some colligative properties. What are the optical property? When I pass the light through the colloidal solution, what will be happen? That is called as optical property. Next, what are the electrical property? Due to the charge of the sole particle or due to the charge of dispersed medium, it can exhibit some properties. That is called as electrical properties. Next, what about the kinetic property? The kinetic property is nothing but the moving of sole particles. That can be explained by kinetic property. Then finally, what of the coagulation or precipitation or fluctuations? Here, the coagulation is nothing but sedimentation, or you can say precipitation. So here, the colloidal particles or the colloidal solution can exhibit or it also can be precipitate. So such a property is called as coagulation or precipitation or fluctuations. If you discuss these are that's all about the properties of colloidal solutions. Now we will see what about the physical properties of colloids. The first one, color. The color of the sole is not always the same as the color of the substance in bulk. For example, the bluish tints is given by diluted milk in the reflected light, and red tints in transmitted lights. So, in the color of the solutions, if you depend on the solution, depend on. For example, the blue tints in a diluted milk in the reflected light. So, light reflected and the milk is bluish color. That light transmitted, it has gives a reddish color. So, here the color does not depend upon the substance in bulk. The color of the sole generally depends on the following factors. The factors are method of preparations, wavelength of source of light, size and shape of the colloidal particle. Otherwise, whether the observer used the reflected light or transmitted light. So, நம்ம என்ன சொல்ல போறோம்னாக்கா இப்போதான் சொன்னோம் அந்த கலர் வந்து அந்த சப்ஸ்டன்ஸை டிபெண்ட் பண்ணி இருக்காது. இப்போ எதெல்லாம் டிபெண்ட் பண்ணியிருக்கோம்? மெத்தட் ஆஃப் ப்ரிப்பரேஷன், நம்ம எப்படி ப்ரிப்பேர் பண்ணுறோம். ஸோ டிபெண்ட் அப்பான் த மெத்தட். நெக்ஸ்ட் தி வேவ்லென்த் ஆஃப் சோர்ஸ் ஆஃப் லைட். ஸோ எந்த லைட்டை யூஸ் பண்ணி நம்ம வந்து colloidal சொல்யூஷன் ப்ரிப்பேர் பண்ணுறோமோ அந்த லைட்டை பேஸ் பண்ணி என்ன பண்ணலாம், கலராக சொல்லலாம். நெக்ஸ்ட் த சைஸ் அண்ட் ஷேப் ஆஃப் த பார்ட்டிகல். அதோட சைஸ் அல்லது ஷேப்பை டிபெண்ட் பண்ணியிருக்கும். வெதர் த அப்சர்வர் வியூஸ் த ரிஃப்ளெக்டட் லைட் ஆர் டிரான்ஸ்மிட்டட் லைட். ஸோ நம்ம லைட்டை பாஸ் பண்ணும்போது ஸோ அந்த அப்சர்வர் அந்த சயின்டிஸ்ட் எதை பேஸ் பண்ணி அவர் அப்சர்வ் பண்ணுறாருனாக்கா, சப்போஸ் லைட் ரிஃப்ளெக்ட் ஆகும்போது இட் ஹஸ் கிவ்ஸ் ஒன் கலர், அதே அந்த லைட் டிரான்ஸ்மிட் ஆகும்போது இட் ஹாஸ் ஒன் கலர். ஸோ பேஸ்ட் ஆன் தட் யூ ஹேவ் டு சே த கலர் ஆஃப் த சொல்யூஷன்ஸ். Okay, next, what of the size? The size of the colloidal particles range from 1 millimicron to 1 millimicron to 1 macromicron. So that is the diameter. So என்ன சொல்ல போறாங்க, அந்த ரேஞ்ச் வந்து எதுல இருக்கும், 1 millimicron to 1 macromicron. Next, what about the colloidal solutions are heterogeneous in nature, having two distinct phase. இப்போ தான் சொன்னோம் colloidal solutions எல்லாமே heterogeneous, not any homogeneous. So homogeneous இருந்தா அது என்ன சொல்லுவோம், two solutions சொல்லுவோம். Heterogeneous என்ன சொல்ல போறேன், it has can exist in two phases. So what are the experimental proof for that? Though the experiments like dialysis, ultrafiltration and ultracentrifugation clearly show the heterogeneous nature in the recent times, colloidal solutions are considered as borderline cases. அப்போ என்ன சொல்ல போனாக்கா, ஸோ பேஸ்ட் ஆன் த டயாலிசிஸ், அல்ட்ராஃபில்ட்ரேஷன் அண்ட் அல்ட்ராசென்ட்ரிஃபிகேஷன் இந்த எக்ஸ்பீரியன்ஸ் எல்லாமே நமக்கு என்ன ப்ரூவ் பண்ணுது, த colloidal solutions எல்லாமே எனக்கு வந்து heterogeneous நேச்சர்ஸ் இருக்குது. நெக்ஸ்ட் what about the filtrability. ஸோ நம்ம இந்த மாலிகுலை வந்து ஃபில்டர் பண்ண முடியுமானாக்கா, ஸோ we know that so the colloidal solutions can be filtered by a special shape of filter paper. So that is called as a ultra filter. This is ultra filter. Ultra filtration பாத்துருப்போம். Ultra filter is made by a gelatin or colloidal. Colloidal. அதாங்க சொல்ல போறோம். As the size of the porous in ordinary filter paper are large, the colloidal particles easily pass through the ordinary filter paper. So ordinary filter paper உடைய size அதோடைய ஹோல்ஸ் எல்லாமே ரொம்ப எனக்கு பெருசா இருக்கும். அப்போ ஆல்ரெடி filter paper நம்ம வந்து colloidal solution நம்ம filter பண்ணும்போது அது ஈஸியா பாஸ் ஆகி வெளியே வந்துடும். ஸோ யூ cannot be used as a ordinary filter paper. ஸோ இது என்ன தெரியுதுனாக்கா, ஸோ the size of the colloidal particles are very small. So for that you have to use a special type of filter paper. So that is called as a filterability. Next, what about the non-setting in nature? Non-setting naaka இது வந்து எனக்கு settled ஆகுமா ஆகாதா அப்படினா ஒரு மாதிரி சப்போஸ் நம்ம suspension solution chalk in water chalk powder water dissolve பண்ணிக்கும்போது it shows the two layer. So the chalk powders can be settled down in the bottom. அப்படி பாக்கும்போது the colloidal solutions are quite stable. They are not affected by a gravity. அப்ப நம்ம colloidal solutions நம்ம எப்படி எடுக்கறோமோ அப்படியே தான் இருக்கும். அது கண்டிப்பா கிராவிட்டியால அஃபெக்ட் ஆகாது. அப்ப எந்த ஒரு டிஸ்டர்பன்ஸும் பண்ணாத வரைக்கும் அது வந்து கீழ எனக்கு செட்டில் ஆகாது. Okay, it's very stable. If I do any disturbance, what the disturbance means, if I add up some of the ions or third party material, it can be settled down. So we'll see later. So generally சொல்லும்போது colloidal solutions are quite stable. That is, they are not affected by a gravity. Next, what about the concentration and density? When the colloidal solution is dilute, it is stable. When the volume of the medium decreases, coagulation occurs. Generally, the density of salt decreases with decreasing the concentration. அப்ப என்ன சொல்ல போறனாக்கா, colloidal solutions எல்லாமே dilute ரொம்ப dilute இருக்கும். It is a very stable. அப்ப வால்யூம் டிக்ரீஸ் ஆகும்போது coagulation will be occur. என்ன வால்யூம் டிக்ரீஸ் ஆனாக்கா வால்யூம் வந்து அதோட டென்சிட்டி அது கான்சன்ட்ரேஷன் வந்து டிக்ரீஸ் ஆகும்போது coagulation. What the coagulation means? Sedimentation. எல்லாமே ஒண்ணோட ஒண்ணா உங்களுக்கு வந்து கம்பைன்ட் ஆயிடும். அப்ப ஜெனரலா என்ன சொல்ல போறேன், the density of salt particles decreases with decreasing the concentration. Next, what about the diffusibility? What is the diffusibility? It can be diffused or not. So already you know that. So what about the two solutions are easily diffused, but colloidal solutions are not diffused. So that's diffusivity. Unlike two solution, the colloidal let diffuse through the membrane. அப்ப membrane வழியா இது diffuse ஆகும், but நம்ம two solutions compare பண்ணும்போது ரொம்ப ஸ்லோவா எனக்கு diffuse ஆகும். Next, the finally what about the colligative property? What is the colligative property? We know that the properties can be depend upon the number of moles of solution. Such a property is called as a colligative property. Already we discussed in the 11th standard பார்த்திருப்போம் என்னென்ன colligative property ன்றது. So evaluation of boiling point, depressing freezing point. So these all called as a osmotic pressure. These are called as a colligative property. So what is the need for colligative property? So based on the colligative property, we can calculate the molecular mass or the molar mass of the given substance or unknown substance. So here the colloidal solutions show colligative properties, that is elevation of boiling point, dispersion in the freezing point and osmotic pressure. The measure of osmotic pressure is used to find the molecular weight of the colloidal particle. So not only osmotic pressure, we can use the colligative property. We can find what the molecular weight of the given substance. Here we are taking the colloidal particle. அப்போ இங்க இருக்கிற இந்த colloidal particle எல்லாம் என்ன பண்ணுது, it can exist a colligative property because it can made by a solute and solvent. Here solute is called as dispersive phase, solvent is called as dispersive medium. So this also it can be exhibit colligative properties. So what are the properties are? It can exhibit elevation of boiling point, depression in freezing point and osmotic pressure. So based on the colligative property, we can determine what about the molecular weight of the colloidal particle. Finally, what of the shape of the colloidal particle? So it is very interesting to know various shape of the colloidal particle. Here are some examples is there. So இங்க என்ன சொல்ல போனாக்கா, இங்க நிறைய நமக்கு வந்து பார்த்தாக்கா அந்த ஷேப்ஸ் வந்து it depends on different shape is there. கண்டிப்பா எல்லா பார்ட்டிகளுமே based on the size based பண்ணி அந்த shape depend ஆகலாம். So based on the property, so it will shows some different shape is there. So what are the examples are? Here given some examples. First we will take arsenic sulfide. The arsenic sulfide is a spherical in shape. Right? The ferric hydroxide. So it is a blue gold soul. It's a blue gold soul. It has to disc or plate like shape. Disc நாக்க நம்ம யூஸ் பண்ற அந்த disc என்ன சொல்லுவோம், அந்த CD disc. அந்த disc மாதிரி இருக்கலாம், இல்ல வந்து flat-ஆ plate மாதிரி இருக்கலாம். Next, what about the tungstenic acid? So W3O5 tungstenic acid or tungstenic oxide. So it has to rod like that. Okay, இரும்பு ராட் மாதிரி வந்து shape இருக்கும். So this is the shape of the colloidal particles. So these are all called as a physical properties of colloidal. What are the properties are? Color, size, then heterogeneous nature, filterability, non-setting in nature, concentration and density, diffusibility, colligative property, then finally the shape of colloidal particles. Here the color does not depend upon the substance. It depends upon the method of preparation, wavelength of source light arise shape and size of the colloidal particle, whether the observer views reflected light or transmitted light. Next, what about the size? It can exist 1 millimicron into 1 macromicron diameter. Next, what about the heterogeneous nature? In the heterogeneous nature, it can exist here two phases that can be fluid by dialysis, ultrafiltration and ultracentrifugation. So what of the filterability? It is very small size, smaller in size, so it cannot be filtered by using a ordinary filter paper. Because of the filter paper has a larger size, when you use it, so the colloidal particles are easily pass through the ordinary filter paper. Next, what of the non-setting in nature? The colloidal particles are quite stable. So this does not affect by a gravity. Next, what are concentration density? When you increase the density, when you decrease the density, the concentration also, when you decrease the concentration, so the density also decreases. Density decreases. What about dissipability? So unlike two solution, the colloidal solution, the colloidal particles are diffuse rarely through the membranes. Next, what about the colligative property? So colligative property is nothing but the properties which are to depend upon the number of moles of solute. Such a property is called as a colligative properties. So here the colloidal solution can be exhibit, can be shows some of the colligative properties such as elevation of boiling point, difference in freezing point and osmotic pressure. So based on the colligative property, we can easily determine what about the molecular weight of the substance. Next, what are the shape? So here the colloidal particles can be exist as a different shape is there. So the shapes are, they are given some examples. The first one, arsenic sulfate, is a spherical in shape. Whereas ferric oxide, ferric hydroxide, it has disc or plate-like shape. Whereas tannic acid, it has to rod-like shape. So that's all about the physical properties can exhibit by a colloidal particles.